Okay, now we're going to learn how to interpret chemical equations using our knowledge of moles. So we look at this first example. Calcium is reacting with water to form calcium hydroxide and hydrogen gas. Okay, we did a similar thing in class where we put some sodium in water and we produced sodium hydroxide and hydrogen. So you can see that it's a fully balanced equation where there's one calcium reacting with two water to produce one calcium hydroxide and one hydrogen. So what does that mean in terms of our knowledge of moles now? So this equation can be read as 1 mole of calcium reacts with 2 moles of water to produce 1 mole of calcium hydroxide and 1 mole of hydrogen gas. And we call this concept the molar ratio. So how does that apply, or how can we apply the molar ratio in a scenario where we're given maybe the mass or the volume of one of the substances and we're asked to work out the mass or the volume of another particular substance? So let's have a look at how we would do that. So here's our question. 50 grams, or 50.5 rather, grams of calcium reacted with water. What mass of calcium hydroxide formed? So we're given the mass of calcium and the question's asking us to work out the mass of calcium hydroxide, one of the products. So step 1 of the process is to write the balanced chemical equation. Because we've already done that, we'll just pop our equation back up here. We need to make sure it's balanced, otherwise our molar ratio will be incorrect. So that's really important. You make sure all of the substances are fully balanced. Step 2 is you write the molar ratio. My tendency is to write the molar ratio straight underneath the equation. So we don't have to write it in sentence form. We can actually just write it as a simple ratio. So 1 mole of calcium reacts with 2 moles of water to form 1 mole of calcium hydroxide and 1 mole of hydrogen gas. So that's step 2 done. So all you do is you use the coefficients that you obtain from balancing the equations in order to calculate in order to work out the molar ratio. So once you've done that, we're actually now up to step 3. Which is calculate the number of moles for the given substance. So in this particular equation, the calculation, we're given the mass of calcium. So we need to work out the moles of calcium here, because as we know from all of our other equations, everything that we want to work out goes through moles. Okay, so the number of moles of calcium is equal to, in this particular instance, I'm given mass, so I would work out mass over molar mass. So the number of moles then of calcium is equal to 50.5 over 40.08. Okay, and if we plug that into our calculators, we get the answer 1.259 ... moles. And we obviously don't round until the end. Next up, we then actually are going to use the molar ratio to work out the number of moles of calcium hydroxide. So how do we do that? We know from the top here, calcium, 1 mole of calcium reacts with 2 moles of water to produce 1 mole of calcium hydroxide and 1 mole of hydrogen gas. So if we're only looking at calcium to calcium hydroxide ratio, the molar ratio is actually 1 to 1. So therefore, if the number of moles of calcium is 1.259 ... the number of moles of calcium hydroxide that would be produced is also 1.259 ... moles. And it's as simple as that. You just use the molar ratio in order to work out the number of moles of your unknown. Okay, in this particular instance, that was calcium hydroxide. So we keep moving forward in order to try and answer that question. So if we look at, just bring that question back down, we're looking at what mass of calcium hydroxide is formed. So we're actually being asked to convert the number of moles to a measurable quantity. In this particular instance, we're asked to calculate the mass of calcium hydroxide. So if we look back at our molar equations, we know that the number of moles times by the molar mass gives us the mass of a particular substance. So in this case, we're looking at 1.259 ... don't round until the end, of course, times by 40.08 plus 16 by 2 plus 1.008 by 2. Okay, and that actually gives us, should give us 74.096. So if we times that by 1.259, we get an answer of 93.4 ... Okay, we're going to leave it at one decimal place here. So 93.4 grams. And that is how you complete any particular calculation using the balanced chemical equation and converting the balanced chemical equation into a molar ratio.